Hi there, welcome to our third lesson of nature of the roots. So on this one, we're going to talk about the questions that you should expect in an exam. So now, most of the time in an exam, they ask you for which values of x. Most of they like to use k. They'll say for which values of k. For which values of k will the equation have equal roots? So now, remember that the discriminant can be used to calculate the unknown value of k. So what you have to do is that you need to ask yourself for which values of k will the discriminant be 0. Remember, when we say equal roots, we just have to go to our map. So you just have to check your map. When we say it has equal roots, can you see the word equal roots? So when we talk about two equal roots, it's when the discriminant is what? It's when the discriminant is equals to 0. So what you have to do is to ask yourself, for which values of k will the discriminant be 0? You need to listen to the question first. When they say, for which values of k will the discriminant have unequal roots, this tells you that the discriminant must be greater than 0. When they say, for which values of k will the discriminant have no real roots, this tells you that the discriminant must be less than 0. For which values of k will the discriminant be real roots, the discriminant must be greater or equals to 0. Now let's try to work this one out. For which values of k will the equation have equal roots? So now ask yourself, for which values of k will the discriminant be 0? There are steps that you need to take to work this thing out. The steps that you need to take to determine the values of k using the discriminant. First thing first, make sure that you put your equation in standard form. That's the first step, which is very, very important. Second one, you have to sub in your correct values and calculate the discriminant. Remember, find your ingredients. So you need to find your ingredient, the value of A, the value of B, and the value of C. Then you're going to equate the discriminant to 0 and solve for k. Let's do one example. Let's say the first example, for which values of k will the equation have equal roots? So the first one, number one, let's say we are given x squared. This shows up everywhere in an exam, this type of question. So it's x squared plus 2kx. It's equal to minus 4x minus 9k. Step one, you must make sure that, number one, to solve this thing, one, put this thing in standard form. Very important. Standard form. When we say standard form, we are talking about the form of a quadratic equation. Ax squared plus bx plus c. So we need to arrange this thing to put it in standard form. So to arrange it in standard form, we'll have x squared plus 2kx. The 4 will come, then minus 4 will come this side to be positive 4x. Then we need to move the 9k also this side to be positive 9k. We equate this to 0. So now it is very important that you know what is the value of b, what is the value of c. So can we see that we have two variables that have the coefficient of x? We have 2kx and 4x. So now we can't have two values of b. We need, because we can't combine these two. These are not the like terms. This have 2k and this one is just 4. We can't add these two, so the best way to make it one term is to take out the common factor. So it will be x squared plus the common factor here, it's x. So now we can write this thing as 2k plus 4. So now can you see that the value of b will be 2k plus 4. So you take out the common factor, then you'll have 9k, which is your constant number. Remember that our variable is x. So any number that doesn't have the x, we're going to consider that number as what? We're going to consider that number as our constant value. So now what's next? We need to do what? We need to determine the value of A, the value of B, and the value of C. So the value of A is the coefficient of x, which is 1. I'm going to write it here. That is 1. The value of B, it's your 2k plus 4. That's the value of B, 2k plus 4. Remember that the value of B is the coefficient of x. Now we have what? The value of C, which is 9k. Remember, guys, it's just a recipe. Now what you have to do, you need to plug in your ingredients and follow the steps. So now what we're going to do, now that it is in standard form, the second one, we need to do what? We need to calculate the discriminant. We need to calculate the discriminant. Remember the formula for discriminant, the set for which values of k will this be have equal roots, and when it has equal roots, it's when the discriminant is 0. So now we're going to take, for now, let's just calculate the discriminant. Let's leave this part for now and say that the discriminant is equal to b squared minus 4ac. And the value of b, we know that this is 2k plus 4 squared minus 4 into the value of a. We have it as 1 and the value of c is 9k. Plug in your ingredients, follow the steps. So now you can see that you need to expand the brackets here. We need to work the 2k. We need to work the 2k plus 4. We need to work the 2k plus 4. We need to expand that one and say 2k plus 4, 2k plus 4. So we need to say, using the FOIL method, this will give us 4k squared. 2k times 2k will give us 4k squared. Therefore, 2k times 4, this will give us 8k. This times that will give us positive 8k. And 4 times 4 is 16. So if we combine the like terms, this will be 4k squared plus 16k plus 16. So we know that this will be equal to 4k squared plus 16k plus 16 minus 4 times 1 is 4. 4 times 9 will give us 36. So it will be minus 36k. So we can add the like terms and put this thing in standard form. Therefore, if we add the like terms, our discriminant is equal to 4k squared, 16k minus 36k will give us minus 20k plus 60. So now this is in the form of a quadratic equation. So from there, what you're going to do, remember we need to solve for a. Step number 3. On step number 3, you're going to say that we go back. The set will have equal roots, and according to our map, when we have equal roots, it's when the discriminant is equals to 0. So now what we're going to do is that when the discriminant is equal to 0, we need to equate. So step 3, you're going to equate. You equate to 0 and solve for x. You equate to 0 and solve for x. So you're going to take your discriminant, equate it to 0 and solve for x. So our discriminant was 4k squared minus 20k plus 16. Take this, equate it to 0 and solve for x. And the best way to do this is to divide you can just divide everything by 4. So this will give us k squared minus 20 divided by 4 will give us 5k. 16 divided by 4, 4. This is equal to 0. And to solve for the value of k, we can factorize this. To factorize this, this is k, this is k. So now, in order for us to factorize this, we need the factors of 4 that when we multiply or add them, they give us 5. So which is 4 and 1, because we know that the best way to get the middle as minus 5 is to have minus 4 minus 1, which is equal to minus 5. So this tells you that it will be 4 on both sides, and both of them should be negative because of the positive 4. So since it's positive, both of them should be negative. Therefore, now you can use what we call the zero product property. Remember that if a multiplied by b is equal to 0, we can say a is 0, or we can say b is 0. So we're going to take the first bracket equated to 0, take the second bracket equated to 0. Therefore, k will be equal to 4, or k will be equal to 1. Right. So this tells you that k needs to be either be 1 or 4 to ensure that the discriminant of the equation is 0. So the discriminant must be 0 in order for equal roots. So k must be one of these two values. It's either it can be 4 or 1. This is how you solve the nature of the roots. Okay, so this is level 4 question. This is something that it's level 3 and 4 question. This is something that you need to expect in an exam. Right. So now, if you understand this, we're going to, on our next lesson, we'll prove the nature of the roots. We'll prove the nature of the roots on our next lesson. And thank you very much for watching.